So here we are. We're going to start the porting on Dave's Rx8 turbo engine. We're going to be using two templates. We'll use part of a Racing Beat template and an Extreme Rotaries template. This is I think a Racing Beat template, which I've modified, made a bit bigger. And then for the boosted engines, I do a modification to the exhaust, so I'll get into that in a second. But anyway, turbo engine, still wants it to be a Brapper, so we're going to do a little turbo Bridgeport. I've roughly scribed it out. I don't get too carried away with scribing. I overlay my templates as I go to just recheck things anyway, so, and then I retouch them with my marker and then rescribe and rescribe. So anyway, I use the Extreme templates because they go right to the boundary as far as you can go generally towards your water jacket. So I use that to mark my outer edge generally. The Racing Beat template, when you get it, it's quite conservative that way. Obviously the inner path for the seals, the side seals, corner seals, etc. to run, you can't use that or that, of course. So you have to rely on understanding your seal trace, where your seals pass on a racer's engine, with the side seals being further out on the Rx8 rotors. So, yep. You can do it without templates. You can lay the housing down and you can scribe up against the housing and then measure 2 millimeters in this way, and that'll usually give you, and then mark another line, that usually give you a bit of safety net. And then once you take your housing off, you can mark 2 millimeters that side, and that'll leave you about 1 millimeter to the water jacket. So yeah, anyway, that's the secondary ports done. The auxiliary ports, or actuator ports, whatever you want to call them, APB ports, like the auxiliary ports. Again, I've modified the Racing Beat one slightly. The duration will be increased, and yeah, just slightly, very slightly. You'll see people bridgeporting them up here. It doesn't make a Brap anymore, but some people say there's gains to it. I think there'll be gains if you don't bridge them in the primary or secondaries. Then you'll see some gains in the upper RPM maybe, once it gets more airspeed. But again, if you just bridge that and nothing else, the engine wouldn't Brap. So yeah, moving on to the exhausts. We have, I've scribed them out again. You can see there's a mark here. This edge here from factory is 0.5 millimeter or so, or maybe just a bit more, away from the path that the blow-by scraper takes. So that's the third ring you have on your Rx8 rotors. It runs along here. You can see the seal trace kinda on your plates. If you pull an engine apart, you've got your inner control ring, your outer control ring, and then your blow-by scraper. And I've kind of marked them here with some texture, marker pen, whatever you want to call it. So obviously in the pre-MSP engines, they didn't have that blow-by scraper because they didn't have exhaust heat going through the plate. So Mazda, I believe, in the early literature that they put out, they seen premature oil rubber failure on engines. I can't remember the kilometres. It was around a lot, 90,000 K. They worked out that they could fail, so they put this blow-by scraper and, keeps heat out, keeps compression blowing back through, also forcing oil into the engine. A few different reasons, but mainly to keep that heat off the oil rubbers. We did an engine like this with this type of port. It wasn't as refined. It was a bit uglier before I got better at the porting these Renaissance engines years ago, like 10 plus years ago, and we didn't put the blow-by scrapers in, mainly because we bent a couple, pulling them out, so we just left them out. And the engine did 80,000 kilometres before he spun a bearing, and we pulled it down and had no evidence of any heat stress, so no discolouring. The oil rubbers were still fine, so I'm sure it wasn't always going to be a failure for Mazda, but they didn't want it to be the weak link, so that's why they put that in. So anyway, I take them out for boosted engines or big Bridgeport engines. As we know, it's been well discussed, there isn't really a lot of big gains in Bridgeport in Renesas engines because they were designed to remove overlap. But you can keep the same horsepower that you can produce out of these motors standard by Bridgeporting them also. You don't necessarily have to lose power. So one of the things I've realised is when you put these exhausts, the lower you go down, the more you reduce the power stroke, but the louder it gets, so you get more of a brat because it's just louder basically. But you start seeing a dip in the horsepower. So I would do my big Bridgeporting, and I would do this. I would remove this blow-by scraper, and I would start porting them out this way, and then I would take a lot of material out of this edge here, because it's quite square, as you know, and then changing the angle to about 30 degrees, just to get everything just to flow a lot straighter out of the motors. And we've seen some really good gains. I think I haven't seen one beaten yet, from a very reliable tuner in Australia, if not one of the most consistent in the world. Produced decent power, over 200 horsepower from a Bridgeport Renesas. So yeah, this one again is going to be boosted. Is most certainly no daily driver, so if it goes pop, it goes pop. We know the drawbacks of turboing Renesas engines around the compression ratios, the flexy, weaker cranks, lighter rotors, all these things add up. But you know, I've seen plenty of them drive around with 10 psi for years, so it can be done. So we're going to do it, and yeah, more to come on what else goes into this motor. It's by no means a big dollar build. It's just very much a home build for a buddy of mine, and it's just going to have some fun, do some skids. So here we go. I'll try and stop and film as I go because I don't have a good camera set up, but yeah, I'll dot punch my drill hole areas, and then I'll drill them out, and then I'll try and stop and film some of the porting as we go.